Neptune is a truly distant world. It resides far out in our solar system. It is the 8th planet from our Sun. This makes it one of the most remote major planets we know. Imagine traveling billions of kilometers. That is the journey required to reach Neptune. Its vast distance means it receives very little sunlight. This contributes to its incredibly cold temperatures. It is a giant icy world shrouded in mystery. We have only visited it once with a spacecraft. That was Voyager 2, way back in 1989. This distant giant belongs to a category of planets called ice giants. Uranus is its neighbor and fellow ice giant. These planets are different from gas giants like Jupiter and Saturn. While gas giants are mostly hydrogen and helium, ice giants have heavier elements. They contain substances like water, ammonia, and methane. These materials are present as ices or supercritical fluids deep within the planet. Neptune's immense size and icy composition make it a truly unique member of our solar system. Its position so far from the Sun shapes its environment profoundly. Being so far out, Neptune takes a very long time to orbit the Sun. One Neptunian year is equivalent to almost 165 Earth years. The discovery of Neptune itself is a fascinating story. One of the most striking features of Neptune is its beautiful, deep blue color. This vibrant hue is quite captivating. It reminds us of Earth's oceans, but the reason for Neptune's color is very different. It is not due to water on its surface. Instead, the blue color comes from its atmosphere. The atmosphere contains gases that interact with sunlight. This interaction is what gives Neptune its signature appearance. The primary culprit behind Neptune's blue color is methane gas. Methane is a relatively minor component of Neptune's atmosphere. Hydrogen and helium are the most abundant gases, just like in Jupiter and Saturn. However, methane has a particular property. It is very good at absorbing red and infrared light from the Sun. When sunlight reaches Neptune, the methane gas absorbs the longer, redder wavelengths. The shorter, bluer wavelengths are scattered back into space. This scattered blue light is what we see when we look at Neptune. The intensity of Neptune's blue suggests that there might be another, currently unknown, atmospheric component contributing to its color. Neptune's atmosphere is not a calm and peaceful place. It is, in fact, one of the most turbulent and dynamic atmospheres in the entire solar system. Despite its immense distance from the Sun and the resulting low-energy input, Neptune boasts incredibly powerful winds. These winds are the fastest recorded in our solar system. They can reach speeds of over 2,000 kilometers per hour. That is more than 9 times faster than the strongest hurricanes on Earth. The source of energy driving these ferocious winds is still partly a mystery. Neptune must have a significant internal heat source. This internal heat, likely generated by the slow gravitational contraction of the planet or radioactive decay in its core, rises through the atmosphere. It helps to power the planet's incredibly fast winds and dynamic storm systems. The atmosphere of Neptune is primarily composed of hydrogen and helium. As we discussed, methane is also present, giving the planet its blue color. There are also traces of other hydrocarbons and possibly nitrogen. When Voyager 2 flew past Neptune in 1989, it made a remarkable discovery. It imaged a huge, dark, oval-shaped storm system in Neptune's southern hemisphere. This feature was dubbed the Great Dark Spot. It was strikingly similar in appearance to Jupiter's Great Red Spot. The Great Dark Spot was an enormous anticyclonic storm. It was roughly the size of Earth. Winds within this colossal storm system were measured at incredibly high speeds, adding to the planet's reputation for extreme weather. Unlike Jupiter's Great Red Spot, which has persisted for centuries, Neptune's Great Dark Spot proved to be a more transient phenomenon. When the Hubble Space Telescope observed Neptune in 1994, the original Great Dark Spot had vanished. This indicated that Neptune's large storms might form and dissipate on much shorter timescales than those on Jupiter. However, Hubble has since observed other dark spots appearing and disappearing in Neptune's atmosphere. This suggests that such large-scale storm systems are a recurring feature of Neptune's weather. What lies beneath Neptune's turbulent cloud tops is a subject of intense scientific interest and speculation. We cannot see directly into the planet's interior, so scientists rely on models based on its density, rotation, and gravitational field. These models suggest a layered structure. Below the visible atmosphere of hydrogen, helium, and methane, the pressure and temperature increase dramatically. This immense pressure transforms the gases into a hot, dense fluid. This region is sometimes referred to as a supercritical fluid ocean, not made of water, but of these compressed atmospheric components. Deeper still, Neptune is believed to have a mantle. This is not a rocky mantle like Earth's. Instead, it is thought to be composed of a mixture of water, ammonia, and methane ices. Under the extreme pressures and temperatures found deep within Neptune, these substances exist in a hot, dense fluid state. This icy mantle is electrically conductive. The movement within this conductive layer is believed to generate Neptune's unusual and complex magnetic field, which is tilted significantly relative to its rotational axis. Neptune is not alone in its distant journey around the Sun. It is accompanied by a fascinating family of moons. As of our current knowledge, Neptune has 16 confirmed moons. These moons vary greatly in size, shape, and orbital characteristics. Some are large enough to be spherical, while others are small and irregularly shaped, likely captured asteroids or comets. Each moon tells a part of the story of Neptune's complex history and its gravitational influence in the outer solar system. The study of these natural satellites provides valuable insights into the processes of moon formation and capture. The moons of Neptune are named after minor water deities in Greek and Roman mythology. This naming convention follows the theme of Neptune himself, who is the Roman god of the sea. The largest and most famous of Neptune's moons is Triton. It is a truly remarkable world in its own right. Other notable moons include Nereid, known for its highly eccentric orbit, and Proteus, which is one of the largest irregularly shaped moons in the solar system. Triton stands out as Neptune's largest and most intriguing moon. It is the 7th largest moon in the entire solar system. Triton is so large that it is actually more massive than all of Neptune's other moons combined. It is a truly unique world, with a fascinating geology and a very unusual orbit. Unlike most large moons in the solar system, Triton orbits Neptune in a retrograde direction. This means it orbits in the opposite direction to Neptune's rotation. This is a strong indication that Triton was not formed around Neptune, but was instead a dwarf planet captured from the Kuiper belt. The surface of Triton is one of the coldest places in our solar system. Temperatures hover around a frigid -235 degrees Celsius. Despite this extreme cold, Triton is geologically active. Voyager 2 images revealed a young, relatively crater-free surface. This suggests ongoing geological processes are resurfacing the moon. Most remarkably, Voyager 2 observed active geysers erupting plumes of nitrogen gas and dark dust particles several kilometers into Triton's thin atmosphere. While Triton often steals the spotlight, Neptune possesses other fascinating moons that contribute to the planet's complex system. Nereid, the 3rd largest moon of Neptune, is particularly noteworthy for its incredibly eccentric orbit. Its distance from Neptune varies dramatically, from about 1.4 million kilometers to as far as 9.7 million kilometers. This makes its orbit one of the most elongated of any moon in the solar system. This unusual path suggests that Nereid might also be a captured object, or that its orbit was significantly perturbed, perhaps during Triton's capture event, which would have caused immense gravitational disruption. Proteus is another significant moon, the 2nd largest after Triton. It is an irregularly shaped body looking somewhat like a lumpy potato. Neptune, like the other giant planets in our solar system, possesses a system of rings. However, Neptune's rings are quite different from the bright, spectacular rings of Saturn. They are dark, faint, and relatively narrow. They were first suspected to exist based on stellar occultation observations in the 1980s. where astronomers watched stars pass behind Neptune. These observations showed brief dimmings of starlight, hinting at the presence of ring material. The Voyager. Two flyby in 1989 provided the first clear images and confirmed the existence of several distinct rings. The rings of Neptune are named after astronomers who made significant contributions to the understanding of the planet. The main rings are Adams, Leverrier, Galilei, and the fainter, broader Lassell and Arago rings. The Adams ring is particularly interesting because it contains several brighter sections called arcs. These arcs, named Liberté, Égalité, Fraternité, and Courage, are puzzling. Normally, particles in a ring would spread out evenly. The fact that these arcs remain clumped suggests they might be gravitationally confined by the nearby moon Galatea, or perhaps by other, smaller, undiscovered moonlets. The composition of Neptune's rings is thought to be a mixture of ice particles and dust, possibly coated with organic compounds processed by radiation.